Example 2, the sliding ladder problem. A ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 feet per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? So here we can see that we have a wall, and then here we have the bottom of that. And so we know that we have this ladder that's up against this wall, and we know that it's a 10-foot ladder. Okay, so there's a couple of things that we need to know. We know that this is going to be a right triangle. Okay, and so the one thing we do know is that, again, the ladder's 10 feet, right? And the bottom of the ladder is 6 feet from the wall. So this is 6 feet from the wall, and this is going to represent x. So x is going to equal 6 feet. Okay? Currently, we don't know what y is. So we need to figure out what y is. Okay, now, we also know the rate. Okay, now, if the bottom of the ladder is sliding away from the wall at a rate of 1 feet per second, so that means the rate is sliding at 1 feet per second. Okay? And so what we want to know is how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall. So that means we want to figure out what is the rate here. Okay, so this tells us this represents dx over dt because that represents the variable x with respect to t. And what we're looking for is dy with respect to t because that is the rate of the ladder going down. Okay, so the first thing we need to do now is we draw a picture, and then we want to figure out what is y. Well, since it's a right triangle, we can do that by using the Pythagorean theorem. So we have x squared plus y squared, which is equal to the hypotenuse squared, or if we wanted to, we can call it r squared. Okay, and then we're going to plug the values in. Well, we know that x is 6, so we're going to square that, plus y squared, and we know the value of r, which is the hypotenuse, is 10, and then we're going to square that. So we get 36 plus y squared, which is equal to 100. Subtract 36 from both sides, y squared is going to equal 64. Taking the square root of both sides, we know that x is going to equal 8. And it's going to be positive 8 because we're dealing with the height of the wall. So therefore, we know that y is going to equal 8. Okay, so now we have a lot of information that we need here. Okay, we know that the value of x is equal to 6. We know the value of y is going to equal 8. And we also know that, again, r is equal to 10. And we know that dx over dt is equal to 1. And again, we're looking for dy over dt. Again, that is the rate, or how fast is the rate of the top of the ladder sliding down the wall. So what we need to do is we need to use and look at our equation here. So we're going to look at this by writing x squared plus y squared, which is equal to 10 squared. Okay, and so what we want to do is we want to take the derivative of this. So when we take the derivative of this, if we take the derivative of x squared, it's going to give us 2x times dx over dt. Plus, if we take the derivative of y squared, that's going to be 2y times the derivative of y over dt. And then that's going to equal 0. Okay, so now that we have the derivative, we can plug in the information. We know that this is going to be 2 times, what's x? Well, we know it's 6. And we know that dx over dt is equal to 1 plus 2 times y we know is 8 times dy over dt, since that is what we're looking for. Okay, and now we want to be able to solve, so let's multiply this out. 2 times 6 times 1 is 12, plus this is 16 times dy over dt, and that's equal to 0. And then we're going to subtract 12 to both sides, so 16 dy over dt, which is equal to negative 12. And if we divide by 16, we get dy over dt, which is equal to negative 12 over 16, which reduces to negative 3/4, and that's feet per second. So it makes sense because it is actually going down, so therefore it would be negative, and therefore this is the rate. So dy over dt, which is the negative 3/4 of feet per second, is how fast the top of the ladder is sliding down the wall when the bottom of the ladder is 6 feet from the wall.